Let us calculate electric potential due to various charge configurations. At first, let me talk about the electric potential or electrostatic potential due to this point charge q at its distance r at this point p. So at this point p, the potential can simply be written as kq by r. If charge q is positive, then potential will be positive, and if this charge q is negative, then potential at this point p will be negative. And this potential is always a scalar quantity because this is simply a work done, right? So let's talk about the potential due to ring case first. At center of ring, right? So if I have a ring of charge q and radius r, and if I want to find potential at center of the ring, then potential at the center of ring will be simply I can to calculate potential at center, what I can do is I can simply break this ring in many small divisions like this. So let's say if this charge is dq, this is dq, this is dq, then potential due to this dq point charge at distance r will simply be k dq by r. This is simply small potential at point P. So in order to get complete potential at point P, what I'll do is I'll simply integrate this. Here I can see that potential due to all these dq will be k dq by r, k dq by r, k dq by r. So k by r will become constant and it will come out of the integration, and I have to do the integration of dq. So dq, 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 dq will all combine to give me kq by r. So this is the potential at the center of the ring. If I talk of case 2, potential at axis of ring, let's say, then in this case, if I have a ring having charge q, a point P is there, this is at distance x, and if I have to calculate potential at this point P, then what I'll do is I'll simply break this ring again as in many dq, dq, dq charges, and each dq charge is at a fixed distance from this point P, and this distance can be straight away calculated by x square plus radius of ring square and its under root. So the potential due to this dq, or in fact any other dq, can simply be written as k dq by x square plus r square under root and its integration. So k is constant, x square plus r square, root is constant, dq, integration of dq is simply q. So this will be the potential at a point on the axis of ring which is at distance x. You can here see that all the dq charges at distance this x square plus r square under root. So all potentials gets simply added up because potential is a scalar quantity. So we need not consider the direction of potential or something like that because it's a scalar quantity. So it gets simply added up algebraically. If let me talk about the electric potential due to this at its axis uh, let's say if I'm given with a disk like this, and if I have to calculate the potential to the disk at this point, the disk is given a charge density sigma coulomb per meter square. So then what I'll do is I'll simply consider a simple ring of radius let's say y, and the thickness of this ring is dy. So the charge dq on this ring will be simply 2 pi y dy into sigma. This distance of point P from the periphery of ring is simply, let's say this is x, it will be x square plus y square and its under root. So due to this ring, the point P is at the axis of this ring. So we know that at the axis of ring, electric field is kq by distance. So k dq by this distance x square plus y square under root. Now this is the small potential due to this small ring. If I integrate this from 0 to r, then I'll get the total potential of this point P. So k 2 pi y dy sigma, these are constants, upon x square plus y square under root integration 0 to r. Right? If I put the value of k, which is 4 pi epsilon naught, then what I get is sigma by 2 epsilon naught and integration of y dy x square plus y square under root integration 0 to r. Now to integrate this, what I do is x square plus y square is put equal to t, dt by dy is equal to 2y dy. So this y dy, the value of this y dy can be placed here. So this way we can always calculate. So putting this value of y dy here, what I get is sigma by 2 epsilon naught, y dy is simply dt by 2, and this is root of t. I have to integrate this sigma by 4 epsilon naught t to the power minus half plus 1 upon minus half plus 1 sigma by 4 epsilon naught and into 2, this is root t. So sigma by 2 epsilon naught x square plus y square under root limit from 0 to r. Sigma by 2 epsilon naught r square plus x square root minus x. So this is the potential at this point P. So this way we can calculate the potential of any point which is present at the axis of the disk at this point P. Like we can consider one more special case. One more special case can also be considered, where if x is 0, then Vp is potential at center of disk, right? So if we put x is equal to 0 in this above expression, then we get potential of the center of disk, which is sigma by 2 epsilon naught into r, by putting x is equal to 0 in above expression.